The last thing we have to do in this unit is our word problems. So again, if you're in physics, you've seen a lot of this before because parametric equation problems are physics problems. So the two equations that we're going to use are here. We have our x equation, our y equation. So let's break down all these variables. V naught is our initial velocity. Theta is our angle. T is time. H naught is initial height. Velocity, angle, time, okay, so that's it. Okay, so let's take a look at number 1. We're gonna find the maximum height and distance if your angle is 60 degrees and your initial velocity is 88. Now notice the thing that they don't tell us is initial height. If they ever don't tell you that, that's you to assume that it's 0. So I'm gonna start by doing my x equation. So 88 cosine 60 all times time. And then my y equation, the initial height is 0, but I have 88 sine 60 times t minus 16t squared. Okay, in order to solve this, we're going to be using a calculator and we're going to graph. But in order to graph in my calculator, we're in f of x, so I need a rectangular equation. So kind of like what we did in the last video, we're going to rewrite our equation here to solve for t. So if I want t by itself, t is being multiplied by all this, so I just got to divide by all this. So x over 88 cosine 60. And I'm going to take what t is and plug it in for both of these t's when I go to graph. So everybody get your calculator because we need to practice typing this in together because this is the biggest error that you'll have is not knowing how to type it in the calculator. So make sure you're practicing this. So I'm going to start with y equals, we'll use our parentheses, 88 sine 60. Outside of all those parentheses, now we have t. So I'm going to do times, and I'm going to force the fraction because our t equation is a fraction. So x over 88 cosine 60. Okay, arrow out of that. Now we have minus 16t squared. So minus 16. And now the 16 isn't squared, just the t. So I'm going to use parentheses and do my fraction again. X over 88 cosine 60. And then don't forget to square that. And then press enter. Okay, it looks like a linear function, but we just got to zoom out. Zoom out. Okay, so here is our parametric equation. Now, if you're not there yet, go ahead and pause this video until you get your calculator to look like mine. But if you're good, let's keep on going. So we have to determine the max height and distance. So max height would be here. So I'm just going to analyze my graph for the maximum. Go to the left, go to the right, and I have a point here. I have an x value and a y value. Well, if I'm dealing with height, my answer is the y value. So my max height will be 90.75. And what's our unit here? Feet. Okay, The other piece is max distance. So say this was like a ball thrown, our max distance would be over here. So if I analyze my graph, that's an x-intercept over there, AKA a 0. So I'm gonna go here. Again, your distance is the x value. So that's this 209.5, we'll say 8. So max distance is 209.58 feet. And that's how you'll solve these problems. Yay. Okay, let's clear our calculator to do another one. So this one we have an actual story to go along with. A baseball leaves a bat with an initial velocity of 152 feet per second. Let's make a note of that. Initial velocity is 152. The angle of elevation is 20. The ball is 3 feet above the ground when it's hit, so that's our initial height. And then you have a 20-foot fence that's 400 feet away from home plate. Now I don't know anything about that yet, so I'll save her for later. So first we're gonna write the two parametric equations. So x equals 152 cosine 20 times t. Y equals, this time we have an initial height. So 3 plus 152 sine 20 times t minus 16t squared. But we know we're going to have to solve for t, so we can go ahead and do that. So x is being divided by that whole section. Okay, so we're going to take all this, plug it into our t's whenever we go to graph. So I'm going to start with my 3 plus 152 sine of 20. Now we're doing times t, so I'm going to force that fraction. So the 152 cosine 20 on the bottom, minus 16, then use parentheses. And don't forget to square outside your parentheses. Okay, so we're gonna zoom out. Okay, so now I feel like I can see everything. So we're gonna sketch what the graph looks like. So I'm starting at 3 feet, and then you hit the wall. Yay. Okay, well, I guess the ball doesn't go underground. We'll erase this. Will the ball go over the fence? Explain. Okay, so let's go back to that fence. The fence is a 20-foot fence that's 400 feet away. So my fence, if it's 20 feet tall, that's the y value. If it's 400 feet away, that's the distance on the ground. 400 feet away, that's the x value. So I need to see what's going on my graph at this spot, because 3 options can happen. Option number 1. We have our fence here. Option number 1 is the ball could go over the fence. Option number 2, the ball could hit the ground before the fence. Option number 3, the ball could hit the fence. And so we're going to figure out what happens in our graph by doing graph trace and typing in this x value. So menu, trace, graph trace, and I want to know what's going on at 400 feet away. So at 400 feet away, my ball is 23 feet in the air. Well, if the fence is only 20 feet tall, that means my ball's over the fence. So we have option 1 here. So will the ball go over the fence? Yes. Explain. Well, at 400 feet, the ball is 23 feet in the air. Yippee! Let's try another one. Okay, now we got a golfer here. So we have a golf ball that leaves a club at 110 feet per second. So I know that my initial velocity is 110 feet. And if you hit a golf ball, it didn't tell us anything about a tee, so I'm assuming my initial height is 0. Angle of elevation of 35. Okay, let's write our two equations. So we'll have x equals 110 cosine 35 times t. Y equals, there's no initial height, so I'll start with the 110 sine of 35 times t minus the 16t squared. Before we can graph it, we gotta get what t is. X over 110 cosine 35. That's who we're plugging in here and here. So let's clear out our calculator and type that in. Woohoo. Okay. 110. Oh, I need my parentheses. No. 110 sine of 35 times x over 110 cosine 35 minus 16 x over 110 cosine 35 squared. Okay, zoom out. Yay. So the first question is, find the maximum distance the ball will travel. So maximum distance is over here. Analyze 0. Come here. So that's the 355.32. And we're measuring in feet. Yes. Okay, the maximum height. So we'll analyze our graph again for maximum. Remember, height is the y value. So 62 point, we'll just say 2. And then we have a 4-foot pole is standing in the line of direction of the golf ball 320 feet down the range. Will the ball go over the pole? So the pole is 4 feet tall. That's the y value. It's 320 feet away. So let's figure out what happens at 320 by doing trace. So at 320, the golf ball is 22 feet high. Is that gonna clear a 4-foot pole? Yeah. Yes. At 320 feet, the ball is, what was it? 22.3 feet high. Yay. Okay, so now that we've done a few, I want y'all to try number 4 on your own before doing it with me. So go ahead and pause the video and try working on number 4, and then push play again when you want to check. So everybody pause. Try number 4 on your own. Help your neighbor out. Make sure they're pausing. Welcome back. Okay, let's check how you did number 4. So the first thing you did is write down all your given information. So your initial height was 78, your initial velocity was 80, and your angle was 45. Then you came and you wrote your 2 equations. Okay, but then you had to figure out t equals, so you divided this. Okay, did you get that so far? Oh my gosh, good job. And now to graph it, you plugged this in for t. Oh, I should have graphed it already. It's okay, I'm really quick. 78 plus 80 sine 45 parentheses times x over 80 cosine 45 minus 16 x over 80 cosine 45 squared. Zoom out, zoom out, zoom out. Ooh, I don't see anything. Oh my gosh. Zoom out, zoom out. Oh no. Oh, there it is. Phew. Okay, so what's our question? If Bilbo can throw 80 feet per second, find the distance the ring travels from the base. So I just need to find this distance over here. That's a 0. So our answer, oh my gosh, it's a beautiful whole number. Did y'all get 260 feet? Yay! Now it's your turn for you and your friends to finish up this packet and do the rest of these problems. They're very similar to the ones that we've been doing. Make sure you check your answers in Schoology and then get ready for your test. Bye!